Everyone, we are going to continue our work with subnetting of IPv4 addresses. In this video, I'm going to demonstrate the next packet tracer activity of module 11, which is 11.7.5, where we have another example of subnetting an given IPv4 addresses and then assigning the addressing scheme to the network devices such as routers and switches. So let's start. So this is how our packet tracer activity looks like. So have a careful look at the topology to just get used to it. We have two routers, we have four switches here, and also we have four PCs. And also it says that each one of these, if you consider it as a local area network, one LAN, it should have at least 25 hosts. So let us also see what is being given over here in the question paper. Let's see. So we have uh, an addressing table which is completely empty, which we have to decide, which we have to deduce, and then fill it in appropriately. And there are two objectives for this particular packet tracer activity. One of it is design an IP addressing scheme. The second one is assign these IP addresses to the network devices and then verify the connectivity. Very much similar to the earlier activity that we did. It is also given, the scenario is written over here. It says that you are given a network address of 192.168.100.0/24 to subnet and provide the IP addressing for the packet tracer network. So once you see this, and I suggest everybody to have a careful look at this prefix notation. Once you see the /24, it automatically means that the first three octets, which is 192.168.100, is your network portion and it should not be touched. So we are not going to touch anything of these three octets because it's /24. And the remaining 8 bits, which is your host portion, we need to do the subnetting. Each LAN in the network requires at least 25 addresses for end devices, the switch and the router. The connection between R1 to R2 will require an IP address for each end of the link. So this is what it has given, and it is saying that there are some certain instructions which are over here. It says the part 1, design an IP addressing scheme. Okay, subnet this particular network into appropriate number of subnets. How many number of subnets? It's been given here. So based on the topology, how many subnets are needed? So let me go back to our topology diagram. So if you see here, if you start counting these particular things, this is one subnet, PC1. PC2 belongs to second LAN, so second subnet. PC3 is the third LAN, third subnet. PC4 is the fourth LAN, which is the fourth subnet. And in addition to these four subnets, we require another one which connects between R1 to R2. So this is another one. So in total, we need 5 subnets. So the answer for that question will be 5 subnets. So how many bits must be borrowed to support the number of subnets in the topology table? Fine. If I need to create 5 subnets, the minimum number of bits required is 3. So 2 cube gives me 8 subnets. If I take 2 bits, I can only provide up to 4 subnets, which is far less than the required 5. So I need to borrow at least 3 bits from the host portion. So how many subnets does this create? If I take 3 bits, I can create up to a maximum of 2 cube, 2 power 3, which is 8 subnets. How many usable hosts does this create per subnet? Fine, it says that how many usable hosts. So if I am taking 3 bits from the host portion, I will be left with 5 bits. So 2 power 5 gives me 32. Out of this 32, as you all are aware, the first address goes for network address and the last address goes for broadcast address. So I will be left with 30 hosts. So for each and every one of this subnet, I can create up to 30 hosts. And if your answer is less than 25 hosts required, then you borrow too many bits. Okay, fine. This is good because my answer is appropriate. So calculate the binary value for the first 5 subnets. The first 2 subnets have been done for you. And in the earlier video, I have shown you how to do this calculation. And I will be doing it again here also. So let me show you how to do these things. So my given network address is 192.168.100.0/24. As I just told you now, the first 3 octets are fixed, which is evident by your /24 notation. So from this, if you want to create 5 subnets, we need to borrow 3 bits. at least 3 bits. These 3 bits, if I borrow, I can create up to 2 cube, which are 8 subnets in total. I can create up to 8 subnets in total. Now, if I take away 3 bits from this host portion, which is this, if I take away 3 bits from our host portion, which is this, I will be left with 5 host bits. Now, of these 5 host bits, which will yield me 2 power 5, that is equal to 32. Out of this 32, I have to remove the 2 addresses which I will be using for network and broadcast addresses. So I will be left with 30 hosts, which satisfies my requirement of at least 25 hosts per LAN. So this is what. Now if I start writing it down here, now let me take this as I told you, I do have the habit. Now the first 3 octets are fixed, 192.168.100. These are fixed. So .0. So here what I'm doing is I am actually once again placing them according to my own convenience as 1, 2, 3, 4, 5, 6, 7, and 8. These are my 8-bit positions of your host portion. So of these 8-bit positions, once again, to make it much more easier, what I will do is I will just write down the powers of 2 at the top. So it will be easy for us. 1, 2, 4, 8, 16, 32, 64, and 128. Now, what happens here is when we want to create 5 subnets, I said we need to take away 3 bits. So these 3 bits are now going to go into the network part. So automatically when I remove these 3 bits, my subnet mask will become /27, which is equal to how much in decimal? So 27 ones, which is equal to 255.255 dot, because all are ones in the first 3 octets, and at the last, because we have how many ones? 3 ones. So the 3 ones in these 3 positions, 128, 64, and 32. So when I have it, my subnet mask will be 224. Please be aware that you have to do the subnet calculations properly. So my new mask after I implement the subnetting scheme will be /27, which is equal to 255.255.255.224. Now let me get back. So for the first subnet, if I take the first subnet, the bit positions will be 0, 0, zeros. Okay. So 0, 0, 0, 0, 0, 0, 0, 0. So this gives me the this gives me the address as equal to 192.168.100. So 100.0/27. This is my first subnet. Now for the second subnet, I place 0, 0, 1. Once again, let me fill all this portion as zeros. I will get 192.168. This is fixed. The first 3 octets are all fixed. Dot how much? 32. So 32/27. Okay. So let me change the color to identify clearly. Let me go for green. And for the third subnet, now my bit positions will be 0, 1, 0, which is once again, let me place all zeros in this part. So my third subnet address will be 192.168.100.64/27. So let me change this again so that it will be easier for us to identify. Let me take for the fourth subnet. Okay. So for the fourth subnet, what I will be getting here is 0, 1, 1, all zeros again here in these bit positions, which is equal to 192.168.100. How much? 96. 64 plus 32/27. So these are the four subnets, and for the fifth subnet, let me take another one just fun sake and also for visibility sake. I like to play with colors. So for the fifth subnet, my decimal positions will be 1, 0, 0. So let me put in all zeros in these bit positions again. And now what I will get is 192.168.128/27. Now I got my desired 5 subnets here. These are the 5 subnets which I require for assignment of the IP addresses according to my scenario. But as I have taken 3 bits, I can still go on doing this subnet until I can actually go for, let me write these remaining 3 ones in another completely different color so that you can identify it. So I can go for even the 6th subnet and then the 7th subnet and then the 8th subnet. Okay. So for these things, what I need to do is I need to get the bit positions here. So after 10, 1, 0, 1. What will be the address here? The subnet one 192.168.100.160/27. So this is the 6th subnet. For the 7th subnet, the binary bit positions will be 110, which equates to once again the same address dot how much? 192.192/297. And for the last subnet, I have the 3 ones in these bit positions, which will equate to 192.168.100.224/27. So these are the remaining 3 subnets which are not used here because I don't have the requirement. This can be kept for future usage, which are not used. Okay. Now, this is how you create these subnets from a given IP address based on the requirement of how many subnets you require, and also you have to take into consideration the number of hosts you need. Okay. So now, because as we discussed earlier, once you have decided what the subnets are, we also should be aware of what is the first host address, last host address that we use in these things. Okay. So this is how you do it. I hope everybody understood it. So let me go back to the particular Word document which I created so that it will be easier for us to enter these details there. So this is the Word document we have. This is given in your particular question sheet. And if you write down here 0, 0, we already did this. So I'm just writing it down once again, the same thing, 0, 1, 0. And all the remaining ones are 0, 0, 0, 0. And if you write here, it will be 0, 1, 1, and then all zeros. These are the bit positions in your last host portion, the 8 bits. And finally, we have 1, 0, mistake, 1, 0, 0, and all zeros. Okay. So this is how you got it. And once again, the binary and decimal value for the new subnet mask. Now, as I told you, the new subnet mask is /27. So these are my bit positions. I need to place 3 ones here. That's all. 1, 1, 1, and all the remaining ones are zeros. The last. So when I have this, these bit positions are 255, 255, 255. This goes 128 plus 64, 192, 192 plus 32, which is equal to 224. So my new subnet mask will be 255.255.255.224. Okay. So now this is what I am very much interested about. If you see the subnet number, the subnet address, the first usable host address, the last usable host address, and the broadcast address. So if you remember correctly, we actually just calculated the different subnet addresses from the given bit positions. The first subnet address will be 192.168.100.0. In this, the first address will be 192.168.100.1. To the last usable address, we get 192. I will simply copy paste this thing so that we can save a lot of time. We have to fill all these details. Usually when you get such things in exam, you take a piece of paper and work on it, which will be much more easier. And the broadcast address will be, last one will be 31. So similarly, you have to fill all the details in this table, which is 32, enter. Next comes 33. All this, the subnet mask is the same because we are using the fixed length subnet masking. We are not using VLSM here. It remains the same. And the last host address will be 62. And finally, we get 63. And here, this we will get the next address. Okay. And here we will get the next one, 65. And then followed by 94. The last address will be 94, and for here it will be 95, the broadcast address. If you remember correctly, the subnet address, which is your network address, and the last address, which is your broadcast address, is never assigned to any host. We will not assign it to any host. 96, we will get 97, and we will get 126. Let me copy paste it, 126, and then we'll have here as 127, which is your broadcast address. This is the fifth subnet, 128, and here it will be 129, and here we will go for 158. Here it will be 159. That is your broadcast address, which comes for the next network address, which is 160. We just calculated all these things. I just shown you how to calculate these things. It will be here as 161, which is the first usable host address, and then we will have 190. So we'll have 30 host addresses in each and every subnet. According to our calculations, 190. This will come up to 191. And then we'll go for 192, and once again we have 193, and then we'll go for 222, and we have 223, and we come to the last eighth subnet. 224 will be the network address. The first one will be 225, last one will be 254, and the last one will be 255. This is how you do it. So this is my subnet table. Once I have my subnet table, there are some certain rules which are given over here for assigning the addresses to the given topology or to the given packet tracer network. Now it is saying that assign subnet 0 to the LAN connected to gigabit 0 by 0. Okay, fine. It is saying the first one should go for LAN for 0 by 0 interface. If you check out the topology again, if you see the topology, so it is saying this network should get subnet 0. This, let me show you much more clearly. So it's saying that this network should get subnet 0. This, when I say this network, this interface also comes under this network, and it is also saying that this network should get subnet 1. Okay, and this network should get the subnet. This network should get the subnet 3. So similarly, if you take these things, so subnet, this is subnet 0, subnet 1, subnet 2, subnet 3, and subnet 4. So in together, we need to assign these different subnets according to the given needs. Okay. So let us see how they are to be given for everyone. Okay. So here. So let's move to the step 3, where you say it's saying document the addressing scheme. These are the different address assignments, and it's saying that fill the addressing table using the following guidelines. Okay, it says assign the first usable IP address in each subnet to R1 for the 2 LAN links and the WAN link. If you remember correctly, what we have is, we have, if you go to the R1, we have 3 links, right? So Z0 by 0, we assign it to S1, Z0 by 1, we assign to S2, and we also have another link S0 by 0 by 0, which connects it to R2. Okay. So now here it's saying that the first usable IP address in each subnet. So G0 by 0 gets subnet 0, Z0 by 1 gets subnet 1, and the WAN link, if you see, is a subnet 4 should be used. Similarly for R2, we have subnet 2 and subnet 3, and once again the subnet 4. For R2, it is asking the last usable IP address of the WAN link. And in the third step, it is saying that assign the second usable IP address in the attached subnets to the switches. So when you are talking about assignment of IP addresses to switches, here we are considering about the SCVI, VLAN 1 interface. And it was also saying assign the last usable IP addresses to the PCs in each subnet. So based on these 4 principles or the 4 rules given, let us fill the details into this particular addressing table. Now, remember the first network address which we have written down here, we just written down it here. This subnet 0 gets the for LAN 1. So this 0 by 0 we have address as 192.168.100.1. This is the first IP address or the first host address that is used, and the subnet mask will be 255.255.255. It's the same IP address, everything. Usually we don't have a default gateway for R1. Okay. So this is the IP address for G0 by 0 interface, which connects it this to, this is the 0. This is the IP address which we are going to assign for Z0 by 0, which connects it to S1. Similarly, for Z0 by 1, we have to assign the first IP addresses of subnet 1, which is 192.168.100.33. Remember in the table, this is what we just written down. See, the second subnet number 1, the first address is 33. The subnet mask remains the same. The subnet mask remains the same. Now, for S0 by 0, it says that assign the last usable IP address. This is what? 2 LANs on the IP address in each subnet to R1 to the LAN links and the WAN link. Okay. Assign subnet 4 to the WAN link between R1 to R2. So which is subnet 4? This is the subnet 4 one. Okay. So the first address is .129 in subnet 4. So what I need to do here, let me copy paste this here, go here, and I have to assign 129. Once again, the subnet mask remains the same for this. We are not using VLSM, so don't bother. And these are the 3 things. The default gateway, we don't have anything. I'll simply merging these things because we don't have a default gateway for R1. R1 actually access the default gateway. So for R2, we have Z0 by 0. Once again, if you go here for R2 interface, for Z0 by 0 interface, it is asking assign subnet 2. So go to the table, subnet 2, this is one. The first IP address is 192.168.100.65. So let me write it down here, 65. The subnet mask remains the same. So to save time, I'm just simply copy pasting it everywhere because we are going to use the same subnet mask for all the address assignments. I simply copy pasted it so as to save some time. Now, what about Z0 by 1 interface? The Z0 by 1 interface of R2 should get subnet 3. So in subnet 3, let me go there. The first usable IP address is this. 192.168.100.97. So let me copy paste it here. Okay, logo got back. It is saying that, okay, assign the last usable IP address for the WAN link, because the first IP address is already assigned to R1. If you remember, I already assigned the first address of subnet 4 to R1. So it is asking me the last address. You pick the last address, you assign it to the R2 interface. Okay, so I assigned it 158. Okay, fine. And after that, what I am supposed to do for the S1s, those for the switches, it is asking me assign the second usable IP address in the attached subnets to the switches. So switch 1 subnet 0. So I should get, what is the second one is .2. Simply I need to write in .2. That's sufficient. S2 should be subnet 1, which should be 34. This is the second address. That's all. I'm doing nothing. And for S3, this is the one, control C, which I should get 66. And here this is subnet 4, control C, subnet 3 actually, 0, 1, 2, 3. This should be 98. Done. So I assigned the IP addresses to switches also. And assign the last usable IP addresses to PCs in each subnet. Now, if you just go check the topology here again, once again, the PCs are all connected to the respective subnets. So PC1 connected to S1, PC2 connected to S2, PC3 connected to S3, PC4 connected to S4. So let me do the assignment. Now, what is the last usable address in subnet? And we have filled it in the form here, subnet 0, which is 30. So let me assign it to PC1, and next comes 62. Assign it here. Next comes 94. Let me assign it for PC3, and next comes the subnet number 3, which is should be assigned for PC4. So that's it. Now we have left out one most important thing, which is the default gateway. Unless until we give the default gateway, none of this works. So what is the default gateway for S1? If you remember, for S1, the default gateway will be the IP address assigned to Z0 by 0 interface. For S2, it will be the IP address assigned to Z0 by 1 interface. Similarly, for PC1, it will be the same default gateway. For PC2, the same Z0 by 1 will be the default gateway. So in this case, for PC3 and S3, the default gateway will be the IP address assigned for Z0 by 0. For PC4 and S4, the default gateway will be the IP address assigned for Z0 by 1. So we have to fill those details here. Okay, so Z0 by 0 interface, which is for S1 and PC1. And similarly, this Z0 by 1 interface will be for S2 and PC2. So what for this, it has to go to the R2. So for S3 and PC3, it will be the same. And again, for for S4, it will be the default gateway address will be the interface address of Z0 by 1 of R2. So I have filled my routing table. Let me see whether I did the assignment correctly or not. So this is my routing table. I filled it. This is how you do it. It's very simple if you understand the concept of subnetting well. So now I didn't do anything on the packet tracer yet. So still it is saying 0%. Now let me go to the part 2. So most of the IP addressing is already configured on this network. Implement the following steps to complete the addressing configuration. Okay. It is also saying that DIGRP dynamic routing is already configured between R1 and R2. So good. So they reduce the work for me. Now it's saying configure R1 LAN interfaces. It is saying that configure both the LAN interfaces with the addresses from the addressing table. Configure the interfaces so that the hosts on the LANs have connectivity to the default gateway. Okay, fine. So what I need to do is very simple. I need to go into R1, press on it, click on CLI, press enter, and enable configure terminal, and then I have to go into interface Z0 by 0. Okay, then I have to type in the IP address assigned for it, which is IP address. If I go here, just to not make any mistake, let me copy paste it, which will be an easier task for us. Yeah, paste space. What is the default gateway that I use, sorry, that which what is the subnet mask that I use, which is 224. So go here and let me paste it over here, 224, and done. Most importantly, no shutdown. If you don't use no shutdown, your interface will not be activated. So that's it. I have activated one interface of R1. Now let me do the same thing for in the other interface Z 0 by 1, which connects R1 to subnet 2. This is the interface address. So let me go there. Let me go here. So this is actually quite easy. I can simply go down to IP address. And what is the address which I should give? If you see, the address which I should give is this 33. So let me go here and type in 33, enter, and simply press the up arrow, no shutdown. Okay, so I think I'm done here. So let me see how much is completed. It's completed 46%. So I did this, done, this done, and it says configure IP addressing on S3. It's only asking me to do the S3. Okay, so let me go to the S3 part. Where is S3? This is the S3 now. In fact, it used to be red color. Now once we assigned everything and once we press the no shutdown, they actually came back to green. So let me go into S3. Let me click on CLI, press enter. So enable configure terminal. Now it is asking me to assign interface VLAN1. What is the IP address that I usually assign here? You see, once again, in order to make sure that you don't do typing mistakes, you can copy paste these things. IP address, use tab wherever necessary if in case you need it. And let me go back here for the subnet mask. Okay, Control C, type it here, come to S3 space, paste, enter, no shutdown, enter. Now I still have to give the IP. Okay, let me come out for giving the IP default gateway address. IP default gateway, IP default gateway address. What is the default gateway address which I have here? This is the default gateway for S3. Please make sure you are selecting the right IP address for the right switch. If you don't do this properly, you won't get the answers properly. Okay, so let me press enter and exit. Let me see what else we need to do here. Okay, so I come here, says to 80% completed. So it is also once again saying that PC4 should be given the hosted in the default gateway addresses. Okay, fine. Where is my table? PC4. This is the IP address assigned for PC4.126. So let me go to the PC4, go to desktop tab, go and then click on IP configuration, click here, and let me type in tab. So I can simply do 224 here. There is no default gateway present. So I have to select the default gateway, which is this. Control C, and let me take you here again and we do the default gateway address. Let me show you. Okay, let me close this. Let me see how much is left over. It says completed 100%. I think we are done. So, but to be on the right side, let me see whether I can ping others on the network or not. So what is the IP address of PC3 in the table? The PC3's IP address is this. So let me check this, whether I can ping PC3 or not. Okay, so see this, go to command prompt, ping, give the IP address here, enter. It should ping maybe one after one or two because there are some protocols which need to be done. 1 2 see, I got the ping working. It is working fine. So let me also ping PC1 and then we'll close it. So what is the address of PC1? The address of PC1 is this. So let me try to ping that and then we'll close it out. So ping is going out of this network. So if the link between R1 and R2 is not configured properly, you will not get this ping. So this, you see, we got it, and I hope everything's fine now. So coming to the end, so this is how you design an IP addressing scheme from a given address based on the requirements. Still, we are using a fixed length subnet mask. That means the subnet mask remains the same for all your subnets that you create. In the next video, we will try to find out how VLSM works and what is the advantage of going for VLSM. So thank you very much.